some field-based courses that I took at the U of A from between 2015 and 2017. So this is an example of a gneiss banding pattern. Gneiss is a high-grade metamorphic rock, which means it has been under high heat and pressure to create that nice little banded pattern. I took this picture in 2017 near Revelstoke, if I'm not mistaken. Next up, I have a panoramic picture of an outcrop. I'm not sure if you can clearly see this in your view, but if you look closely, you can see some diagonal veining patterns, and you can see some vertical fractures. So fractures form whenever a rock is under stress, and then veins form when a fracture gets infilled by crystal growth. And then here I have a close-up example of a vein. From this picture, it's hard to tell if this is quartz or if it is calcite, but if you are in the field, one of the best ways to tell the difference is to pour some hydrochloric acid along it, and if it fizzes, it would be calcite, because calcite is a carbonate, which means it would react with acid, similarly to how vinegar and baking soda fizz when they touch. And quartz, however, would not fizz if touched by acid. Another test you could do in the field is a hardness test, because quartz has a harder Mohs hardness scale value than calcite. So calcite would be easier to scratch than quartz if you don't have your hydrochloric acid. Okay, here is an outcrop of shale, which is a common sedimentary rock made of clay or mud-sized particles, and it breaks into nice thin layers. This shale is red, which means it could have hematite in it, and that means that it formed in an environment with lots of oxygen. Hematite is an iron oxide, which is the fancy word for rust, and there needs to be lots of oxygen for rust to form. This picture was taken in Cranbrook, 2017. Here's another shale outcrop I found in Jasper, 2016. This one is different from the previous image because, as you can see, the shale is black, not red. Black shale formed in a place with little oxygen, and it likely contains organic material or carbonates. And just like the calcite I talked about, a carbonate shale would fizz when you touch it with acid. Next up, I have a picture of the Athabasca Glacier from the Rocky Mountains. This glacier is receding, which means it is gradually getting smaller because it's melting more quickly than it's gaining snow. And most glaciers today are receding. I think you were trying to say hematite. Hematite, I'll go back to few slides, is a mineral made of iron and oxygen. And another example of an iron oxide is magnetite. And they're both formed in rusty environments. I don't have an example that I can physically show you, but I can possibly get back to you with a picture of a close-up hematite sometime. Okay, here's the Drumheller Badlands. I believe the video earlier today that Keith presented had some of these. Badlands are places where there is very little plants and sediments are highly eroded. You can see lots of erosional features. You can see some hoodoos, which I'll show another slide of that later. Due to the erosion, you can see the nice layers or strata, and it's a good place to find coal and fossils. If you've ever been to the Royal Tyrrell Museum, you've probably seen these before, and if you haven't been to the Royal Tyrrell Museum before, you're really missing out because it's a great paleontology museum. So here's another view of some hoodoos. I took this picture in 2015. As I believe Keith said this earlier, the top part is called a capstone, and it's more durable than the sandstone and silt and other particles below it, so it provides us like a barrier, which gives it that long spire appearance. And here's a picture from the Horseshoe Canyon found near the Badlands. The valley forms an almost horseshoe-like shape, and it's a nice place to go for a hike.